Now that we know some things about quadrilaterals and parallelograms and trapezoids and kites, we are going to use the coordinate plane to determine, and our slope, to determine if we have a parallelogram or if we have a trapezoid. So first off, which quadrilaterals have pairs of parallel lines? The shapes that we already know is a trapezoid, parallelogram, rectangle, rhombus, and a square. So how many of pairs of parallel sides do they need to make it, or do we need per figure? So for trapezoid, we need one pair. For parallelogram, rectangle, and rhombus, and square, we need 2 pairs each. For number 2, when we need to show that ABC, so quadrilateral ABCD is a trapezoid, we are basically need to show that we have one pair of parallel sides, so one pair of opposite sides that are parallel. Since we already have the graph drawn for us, the easiest thing for us to do is to connect our points together by making a right triangle. So if you can see, I first set up my paper so that we label all 4 sides so we can find the slopes. Now when we find the first one, we've got a 2 for the rise and a 3 for the run, and this is a positive direction. So our slope would be a positive 2/3. Next, I want you to find what is the slope of side BC. So make a right triangle, count your spaces, and then write it rise over run. Your rise should be a 2, your run would be a 1. So you'd put 2 over 1. Now remember, it's going downhill, so it's going to be a -2 is what you should have put. For the next one, from C to D, there are 4 blocks going up and there are 6 going across. So our rise would be 4, run would be 6, and that is a positive, but that reduces down to 2/3. For the remaining side, when we connect those together, we've got a 4 and a 2, so our rise is 4, run is 2, and it reduces down to 2 over 1, and that's a positive. We only have one pair of sides that are parallel to each other. If you notice, the other ones are not parallel. And the reason that they are parallel is because they have the same slope. So we did use enough information to show us that this is a trapezoid. Number 3 is the same way, except now I want you to show me, is it a parallelogram? So first you need to find the slope of all 4 sides. For my side PQ, our rise is our 2, the run is the 4, and that's going downhill, so it's going to be a -1/2. For my side QR on the far right, the rise is 4, the run is 2, and it's also going downhill, so it'll be a -2. For the bottom side, the rise is 2, run is 4, and it is going downhill again, so it's -1/2. For the last side on the left, your rise is 4, run is 2, and it is negative, it's going downhill, and our slope reduces down to a -2. So if you notice, you've got 2 sides, 2 pairs of sides that are parallel to each other. So that is enough information to show it that it is a parallelogram. Now on to number 4, you can see that we are given coordinates A, B, and not the C, and we have the D. So we're missing the one connecting the B to the D. So make sure when you connect your pieces that you do not connect B to D together. This just tells us that our coordinate we need to find is over here someplace, so we can picture where it needs to go. Now remember, we need our opposite sides need to be parallel to each other. So the side that is AB, we know that DC needs to be parallel to it. So we can kind of picture that the C needs to be over here. AD also needs to be parallel to BC. So we need to find what is the slope of both of those so we can use the slope to connect and extend out those sides. So we need to first find the slope of AB. And if you can see in pink, I drew a triangle on there. So our rise is 5, the run is 3, and that is a negative slope. We know that the side CD also has the slope of -5/3. So the way to find that is we start at point D, because that's all that we have from that segment, and we can use the slope of -5/3 to find another coordinate. Now we don't want to go down 5 and over 3 because we know C is not down here. So if we go up 5 and over 3, that would give us where our point C needs to go. So if we count up 5 spaces, so 1, 2, 3, 4, 5, and to the left 3, that gives us that our point C should be right there. So we want to count the same distance from AD to use our slope of AD to picture where our BC side should be as well. So the slope of AD, we have the rise is 1 and the run is 4. So it'd be a positive 1/4, which we got the slope is 1/4, and our side BC will also have the same slope of 1/4. So now if we count from our point B right here and we use our slope of 1/4, now we don't want to count down 1 and left 4 because that's not where the C ends up. So if we count up 1 and over 4, it should end up at the same place. So if we go ahead and do that, we go up 1 and over 4, and it does give us the same location. So this is where our point C is going to be, which is at 2, 4. And number 5 and 6, we need to determine if the statement is always, sometimes, or never true, and we need to explain the reason why that is. So if we have the slope of side LM is 2/3 and the slope of side NO is negative 3/2, we need to, then they're saying that the quadrilateral LMNO is a parallelogram. Now to make it so it is a parallelogram, we need to make sure the opposite sides are parallel to each other. So if you notice, our opposite sides right here are not parallel. And they need to be to make sure that it is a parallelogram. So the only way it is going to be a parallelogram is if those opposite sides are parallel, and they're not, so this would be never true. All right, so on to number 6. They first tell us that quadrilateral QRST is a square, so there is my square, and it says the slope of side QR is -4. Then they're saying that the slope of side ST is going to be -4. But remember, for it to be a square, we need our consecutive sides need to be perpendicular to make this right angle, and our opposite sides need to be parallel to each other. So if you notice, our opposite sides are parallel. Because we already know that this is a square and one of the sides, we know that the other side will always have to be parallel to it. So if you notice, it is parallel, so this would always be true. For this last question, we need to use the 4 lines that are given, that they create a quadrilateral, and we need to classify that quadrilateral. If it's a trapezoid, a parallelogram, or neither. So we need to find the slopes of each of the lines and then compare the slopes to see how many sets of parallel lines or parallel sides we have to our quadrilateral. So on the very first one, I'm just going to draw arrows on here. Line L already is solved for y, so our slope is just the one that's in front of it, in front of my x right here. So next we need to go to line M, and I want you to find what is the slope for line M. What you should have done is add your x to both sides so you can solve for y to begin with. So we get x plus 0 or just x, and your slope will be 1 again. For line N, I'm going to do that right here. When we solve for y, we can subtract our x over, so we get -x plus 6. We need to divide everything then by a 2. So we get a y equals -1/2 x plus 3. And our m on this one, our slope, is going to be a -1/2. For the very last one, for our line P, this equation could be rewritten as just a -1/2 x instead to make our slope a little bit easier to identify, so it's a -1/2. Now if you notice, these two lines are parallel, and we also have another set of parallel lines. Since we have 2 pairs of parallel lines, or 2 sets of parallel lines, this tells us it is going to be a parallelogram, not a trapezoid. So to recap of what we did, we need to solve for y first on all of the lines if they're not done so. We need to label what the slopes are so that we can then compare the slopes to look for any parallel sides. So if we only had 1 pair of parallel sides, that would be a trapezoid. Since we have 2 of them, that is our parallelogram.